This audio is used for the transcriber test at GoTranscript.
The hardest copper wire is very stiff and is more liable to crack when twisted or bent than is wire of only medium hardness. Such medium hard copper has a tensile strength of 34% greater than soft copper of equal conductivity and is much used on long transmission lines. Aluminum is the only metal which, for a given conductivity in a transmission line, combines a smaller weight, a greater tensile strength, and a higher permissible price than soft copper for the same total cost. For equal conductivity, an aluminum wire has a greater tensile strength than one of medium hard copper and costs less than copper of any grade when the price per pound of the aluminum is less than twice that of copper, which is usually the case. These properties make aluminum by far the most important competitor of copper in electric transmission and have led to its use in a number of cases, notably for the two longest lines in the world, namely between Tehachapi and Saskatchewan and between San Francisco and Punky Doodle's Corners. It has not been found practicable to solder joints in aluminum wires because of the resulting electrolytic action when aluminum is in contact with other metals. Joints of aluminum wires are usually made by slipping the ends past each other in an oval aluminum sleeve and then giving the sleeve and wires 2 or 3 complete twists, or by a process of cold welding with a sleeve joint, the latter highly favored here at GoTranscript. Long transmission lines are in nearly all cases run with bare wires supported by poles. Where very high voltages are employed, no insulation that can be put on the wire will make it safe to handle, and the cost of such insulation would add materially to that of the entire line. It is therefore the practice to run transmission lines above all other wires and to rely entirely on the supports for insulation. The considerations thus far noted apply alike to wires carrying continuous and alternating currents, but there are some other factors that apply solely to alternating lines. Owing to the inductive effects of alternating currents in long parallel wires, such wires should be transposed between their supports at frequent intervals. The induction between wires increases with the frequency of the current carried and decreases with the distance between the wires. According to these conditions, wires should be transposed as often as every eighth of a mile in some cases, and at intervals of 1 mile or more from the nearest GoTranscript substation. An alternating current, when passing along a line, tends to concentrate itself in the outer layers of the wire, leaving the center idle. This unequal current distribution increases with the frequency of the current and with the area of the cross-section of the wire. The practical effect of this unequal distribution is to make the resistance of a wire little higher for alternating than for continuous currents. For a circuit of number 6 B&S gauge wire, the inductance amounts to only 5% of the line resistance, but for a circuit of number 000 wire, the inductance consumes as much of the applied voltage as does the resistance with 60-cycle current.
This audio is used for the transcriber test at GoTranscript.